I have this DeWalt drill and a Makita battery connected together. When I try to drill into this piece of metal, it completely fails. The drill just stops. The battery is completely drained and non-responsive. I'll take the battery off and put it on the official Makita charger to see what's going on. As you can see, it won't charge. The charger indicates that the battery is defective. This usually means the internal voltage has dropped too low for the smart charger to recognize it, so it completely rejects it as a safety precaution. I'm marking this battery with an X on some tape so we know this is the exact same dead battery we started with. Instead of throwing it away, I'm going to open it up to see if we can fix it. I'm using a screwdriver to carefully remove all the screws and open the outer casing. Once it's open, I take a clean paintbrush and meticulously brush away all the accumulated dust and debris from the circuit board and the battery cells. This is a crucial step because fine dust can absorb moisture, potentially causing minor short circuits that mess with the delicate electronics. Leave a comment and let me know which country you are watching from. It's great that we can connect and chat from all over the world. I'm using my multimeter to diagnose the issue. When I probe the individual cell groups inside, they are reading around 3.8 to 4 volts. Here comes the last battery cell. I get exactly 0 volts. This means the battery management system, or BMS, has locked out the output for safety. This tells me the cells themselves are still healthy, but they've likely become imbalanced, which triggered the BMS safety shutdown. To fix this imbalance, I need to make a custom tool to manually charge the lowest cells. I will use PVC pipes to make a homemade battery charging tray. I will use a pen to mark the positions on the PVC pipe to fit the battery snugly. I cut a small section of a standard PVC pipe using a hacksaw. If you find this video interesting, don't forget to like, subscribe, and turn on the notification bell so you don't miss any interesting ideas coming soon. Then, I use a hot air gun to soften the plastic, flattening it out between two wooden blocks to create a strong, flat plastic sheet. I'll heat it one more time and bend the ends over a wooden block to form a sturdy U-shaped clamp. Next, I'm using my drill to make a hole on each side of the U-bracket. I'll insert a metal bolt through each hole and secure them tightly with nuts using a pair of pliers. These bolts are going to act as the precise electrical contact points for my custom charging jig. For the power source, I'm repurposing an old 5-volt USB wall adapter. I cut the end off the cable, strip the insulation to expose the copper wires. I'm using a multimeter to check the voltage of the charger. The voltage displayed is over 5 volts. which is suitable for recharging the battery with the protection lock. I will tightly wrap copper wire from the negative and positive wires around the bolts on my PVC clamp, tightening the nuts to secure them. A solid connection is essential for good conductivity. I plug it in and use my multimeter to confirm that the bolts are now delivering a steady 5 volts. I'm attaching my homemade charging clamp directly to the battery cell cluster that has low voltage. By doing this, I'm completely bypassing the locked-out BMS and providing a slow, gentle 5-volt charge directly to the cells to bring their voltage back up to a balanced level. After letting the battery charge manually for a while, I will loosen the nut and remove the clamp. I'm using a multimeter to test each battery cell. When I get to the original cell with low voltage, look, it's been restored. The voltage of the battery cell after restoration showed nearly 4 volts, as expected. I place the battery back onto the official Makita charger. Look at that. The charging indicator light turns red and stabilizes. By manually balancing the cells, we successfully reset the BMS, and it's accepting a charge normally again. My multimeter confirms the pack is now outputting a healthy 20 volts. I'll carefully reassemble the outer casing, making sure every screw is securely fastened. The built-in indicator shows a full battery. Now for the moment of truth. I attach the battery and adapter back onto the DeWalt drill. Watch how effortlessly it powers through this thick steel bracket now. This simple DIY fix saved a perfectly good battery from the trash. If you enjoyed this project and found it helpful, please give this video a big thumbs up, share it with your friends, and leave a comment below telling me about your own DIY repairs. Don't forget to subscribe for more fantastic DIY ideas. Thank you for watching, and I'll see you in the next video.